Hello everyone, let me share my screen. Let's get started. Before we get into this topic, I want to introduce myself. My name is Andy and I'm a data science student at San José State University now. My hobbies besides school is rock climbing, hiking, blogging, and playing musical instruments. Now, why is it important that we talk about ride-hailing fare prediction? Did you know that the average vehicle occupancy rate is approximately 1.6? That means for every vehicle on the road that you randomly select, there are about 2 people occupying that vehicle. So that means there are 3 to 5 empty seats, depending on what kind of car we're talking about. And this is according to the National Household Travel Survey. And the problem is not getting any better. So let's keep this in mind, and we'll talk more about it in the upcoming slides. So the research problem here is the ride-sharing problem, in which we are interested in finding the optimal fare for customer. And what gives rise to the problem is the fact that urbanization is on the rise. More people are coming to the city, and that means heavy traffic and high commute time. And as a student in the Bay Area, I can relate to this. And additional problems are, it's taking a toll, emotional toll on you, and it affects your work performance. And moreover, more cars mean increased carbon emissions. It's as simple as that. And how are we going to solve this problem? Let's look at the past research. First of all, we have linear regression techniques. This helps us model 2 variables, fare and distance traveled. It's a popular technique, but it does not capture a lot of information that we have. For example, time. And so here we have a time of day models. This model helps us predict fares based on the user activity during the day. You can imagine there are more customers at 8 a.m. than at 5 a.m. So the model will use the price multiplier to decide whether you get a discount or a premium. But this model does not address the inefficient use of empty seats in the car that we mentioned in the second slide. So here comes the coalitional game framework. They incorporate carpooling features to reduce fares among passengers, to encourage more people to carpool on a trip together. So the research gap here is to find an optimal price that can take in time of day, different destinations. And I want to mix time of day models and coalitional game framework to build a statistical model with machine learning capability. It will look at the time of day, distance traveled, the different destinations on the same path that the customers are going to. And the goal is to produce a fair price for customers. How are we going to do this? Let's look at the technical approach. First, we're going to collect data sets. And as with any data, they can be messy. So we want to clean and combine data sets. Third, we will split our data set into 3 distinct sections: training, validation, and test set. For the training data set, we will use it to build our prediction model. Then we will verify its accuracy. If we don't measure how well it does in performing, then we're not going to do a good job producing a model. So we want to verify that accuracy using a performance metrics. Last but not least, we will assess our models on unseen data. These are the data that our model does not see yet. And we want to make sure that it also produces the optimal fair price for customers. Here's our conclusion. There's not one size fits all solution for every city and every country because there are different factors like climate, infrastructure. So the optimal prediction model relies on iterative research. But there's one thing that we know. It is that a good solution will maximize driver earnings and minimize fares. So that way, both drivers and passengers are happy. Thank you for sticking to the very end of my presentation. I hope you have learned something new about fare prediction. Thank you so much.